Hey there! Today we have an interesting problem to discuss. Picture this scenario. We have a C++ program with two threads, each trying to print a timestamp along with the value of a shared variable I. The twist is the output might show I as 0 in the first thread and 1 in the second, even though the timestamp of the first thread is later than the second. How is this possible? Let's delve into the details. In this problem, the key lies in understanding the behavior of the std time function in C++. According to the C++ standard, there are no specific constraints on how std time behaves, leaving room for such unexpected outcomes. However, when it comes to clocks with the is_steady properties set to true, like std chrono steady_clock, the C++ standard mandates a specific ordering of timestamps. So, the use of a different clock type could have influenced the results in our scenario. Solution, Part 2. To ensure proper synchronization and ordering of critical sections in a multi-threaded environment, the spin lock in the program follows the acquire-release ordering. This means that the unlock operation in one thread synchronizes with the lock operation in another thread. Consequently, if we had used std chrono steady_clock, now, instead of std time, the timestamps would have adhered to a strict ordering based on the critical section's execution. In summary, we've explored a fascinating problem where seemingly contradictory outputs are possible due to the behavior of std time in C++. While the C++ standard leaves room for such scenarios, adopting clocks like std chrono steady_clock can ensure a more predictable outcome. Hopefully, you found this discussion engaging and informative. Remember to subscribe, like this video, and comment below with your thoughts. Until next time, happy coding!